Imagine a whole world of technologies that could double your car's power, dramatically reduce fuel consumption, and extend engine life. Sounds like a dream, right? But what if I told you such technologies exist? They're just illegal. Car manufacturers know about them, but they're not allowed to use them. Why? Today you'll find out. I'm not talking about chip tuning, which can be done in any garage. I'm talking about fundamental engineering solutions that are prohibited by environmental regulations, racing federation rules, or patent wars. These are weapons that are too powerful for regular roads. Let's start with the classics, the water injection system into the cylinders. Yes, you heard right. Water. This technology has also been used on jet fighters for short-term power increases. The principle is simple. Water, evaporating, strongly cools the fuel-air mixture. This allows the naturally aspirated engine to operate with much earlier ignition and a high compression ratio without causing detonation, the main enemy of power. Why was it banned? Imagine, you are an automaker. Your engine produces phenomenal performance, but requires refueling not only with gasoline, but also with distilled water. Now imagine what happens to this engine when the owner forgets to fill up the water or, worse, fills it with tap water. Major repairs after 10,000 kilometers. Problems with the ecology of exhaust gases when the system is not working. It's a nightmare for warranty and reputation. Therefore, it was abandoned in favor of more stable but less effective solutions. And now, the real magic of materials. Modern engines are giant radiators. They waste up to 60% of fuel energy just by heating antifreeze and metal. The solution? Cover the pistons, valves, and walls of the combustion chamber with the thinnest layer of ceramic or other thermal insulation material. This is a so-called adiabatic engine. The result? The temperature inside the cylinder remains astronomical. All the energy goes to the piston, not to heat the engine. The power increases, the efficiency goes through the roof. But what's wrong with this utopia? Such coatings are extremely expensive to apply, brittle and unrepairable. And most importantly, when technology is disrupted, they begin to peel off, turning into abrasive dust that instantly kills the engine. Mass manufacturers do not need this, but in the space industry and Formula One, it is very even. The holy grail of engine building is an engine that can be both an economical atmospheric and a powerful turbo. At one moment, you need to change the compression ratio right during operation. Complex systems with movable piston pins, variable connecting rod length, or cylinder block tilt angle are a reality. In a couple of minutes, you will find out why this technology is not on all cars and about additives that turn gasoline into rocket fuel. But why don't we see it on every car? Complexity, cost, and reliability. Each such node is a potential point of failure. Market lawmakers dictate that the engine should travel 200 to 300,000 kilometers without serious interference. The complex mechanics of the variable compression ratio cannot yet guarantee this in mass production. This technology is a blueprint for a future that has not yet arrived. And now the most dangerous and forbidden territory, we are talking about fuel additives that turn ordinary gasoline into pure rocket fuel. I'm talking about nitromethane, methanol, and TNT. Yes, you heard right. During the Second World War, experiments were conducted in the USSR to add crushed TNT to aviation fuel. Additives based on nitroglycerin and other explosives dramatically changed the rate of fuel combustion, creating tremendous pressure in the cylinders and giving an instant increase in power. But the price of this is hellish loads on the piston group. An engine designed for 300,000 kilometers can fail in one race. Such mixtures don't just kill the motor, they tear it to shreds. This is a single-use weapon, absolutely unacceptable for civilian transport and prohibited in any civilized competition.